Hi guys, welcome back. Let's try to solve subset sum problem in this video. Okay, let's define the problem first. I will give you an array, and in this array and I am defining a sum value is 43. So what does this mean is you have to find a subset whose value is equal to 43. If there is any subset like that, you have to return true, else false. Okay, I am mentioning a set over here and I am giving a sum value as 43. So there is a subset like this. So 34, 4, 5. So this forms answer as 43. So we have to return 3. True. Okay, there is one more subset 3, 5 and 35. Okay, this also sum of these elements form 43. So we have to return true. Okay, let's evaluate the options. So from the last element we just keep on decreasing and try to come till the starting of the array. So from here what we do is we either pick the element or we don't pick the element. So let's consider here. So we just pick the element 98. As 98 is already greater than the sum 43, we just ignore 98. Okay, if we include 98 or if we don't include 98 in the answer, it doesn't matter because 98 is already greater than the sum 43. So we just exclude 98. So after excluding 98, this is the subset. So within this subset, what we have to do? We have to find a subset whose sum is equal to 43. Now we either consider 35 or we don't consider 35. Just like in the knapsack problem, we either pick the gold bag or we don't pick the gold bag. So if we include 35 in the answer or if we don't include 35 in the answer, we have to check like that. So let's ignore 35. Then what? In this particular subset, we have to find for a sum of elements whose sum is equal to 43. We have to find elements, subset elements whose sum is equal to 43 if we exclude 35. If we include 35, in that case 43 minus 35, which is 8. So we have to check for subset of elements whose sum is equal to 8 in this particular subset. Okay, we either consider the element or we don't consider the element. If we consider 35, okay, we have to check for this subset whose element sum is 8. If we don't consider 35, we have to check this subset whose sum is equal to 43. Understood? Okay. So whenever the array index falls less than 0, then nothing can be done. We have to return false. Okay, that is the base condition. Let's write the recursive. You will understand much more about it. So this is the problem. Let's write the recursive function is subset. Okay, int index, pass the last index of the last element index, int sum. Okay, we have to calculate the sum. We'll give as 43. Now if set of index is 98, 98 is already greater than the sum 43, then we just ignore, we just exclude that particular element and try to find each subset. Okay, index minus 1 comma sum. Okay, we just ignore 98 and try to find subset, okay, whose sum is equal to 43 in this particular subset. We are just ignoring this one. Okay, now in this subset, okay, in this subset we have to check for sum of elements, okay, subset of elements whose sum is 43. Now we have two options over here. Okay, option 1, either we consider that particular element. So let's ignore 35 for instance, means we are just checking this subset, for group of elements whose sum is equal to 43. So the sum remains same. Okay, next option is we consider this 35. If we consider 35 in the answer, then 43 minus 35 is 8. So we have to check this subset for group of elements whose sum is 8. Okay, we are considering 35, means set of index is 35. Okay, we are considering 35. So we have to find in this subset for group of elements whose sum is equal to 8. Sum 43 minus 35 is 8. Okay, in either of the cases it will return the answer. So what we have to do is we have to return option 1 or option 2. Okay, by ignoring this, is there any group of elements which form 43? Yes, true. By, let's assume there is no subset like this. Okay, then there is one more chance. By considering 35, there is a group which forms, there are group of elements whose sum is 8. Yes, 3 and 5, true. So either this can give an answer or this can give an answer. That's why we are returning option 1 or option 2. Now we have to write the base cases. We kept on subtracting the sum. So if, for example, if sum is equal to 0, then return true. Okay, for example, if sum is equal to 35 only instead of 43, if it is 35, so we found the subset whose value is 35. So we have included 35 in the answer. So 35 minus 35 is sum is 0. So we are just calling this recursively whose sum value is 0. Okay, so sum has become 0. So we are returning true. Yes, we found the answer. So return true. Okay, but the question is for 43. I'm just changed just to explain. Okay, so if sum is equal to 0, then we found the answer, then true. There is one more case. If index is less than 0, okay, index is from 0 to array length minus 1. Okay, if index is less than 0, means if index is less than 0 and sum not equal to 0, return false. Okay, if index is less than 0, so we from here, from last of the array to first element of the array, we keep on recurring. So if index is less than 0, as we are doing minus 1, so 0 minus 1, just consider you have taken the first element index which is 0. So 0 minus 1 is minus 1. Okay, and still you have to find for a subset whose value is some example 10 or 5. Okay, if sum not equal to 0 and index is less than 0, then you haven't found any subset, so you are going to return false. Okay, I hope you understand. So for example, you kept on decreasing the index and you have reached here, and still after reaching here you have to find an output for, okay, you have to find a subgroup or subset whose value is some value. Okay, for example, you have reached an index 0. Okay, what do you do here? After reaching here, you have to find a subset whose value is 4. Either you consider 3 or you don't consider 3. This is the only two options. If you consider 3, 4 minus 3, you have to check for a subset whose value is 1. Okay, you have to check for a subset whose value is 1 here, but there is no subset. Okay, index false less than 0 and sum is 1, which is not equal to 0. So you can't find any subset like that. So you are returning false. Okay, if sum is equal to 0, you are returning true. Else, if index less than 0 and sum not equal to 0, you are returning false. Okay, so now let's try to pass the arguments for this. Okay, how do you find the last element? Size of set. Okay, size of is the operator. Size of set by size of first element, set of 0. Okay, set of 0 gives you number of elements. Okay, let's put it outside to avoid confusion. So array size is size of set by size of set of 0 gives you array size. So array size minus 1. Okay, array length will, array runs from 0 to length minus 1. Okay, now here we are giving sum as 43. Yeah, you have to find for 43. Okay, in this set you have to find a sum whose you have to find a subset whose sum is 43. If there is any subset like that, you have to return true. Okay, let's write cout like this. Yeah, this will work. It just prints whether 0 or 1 in the output. See, so we have found a subset whose sum is 43. Okay, we have found a subset whose sum is 43 in this entire array. Okay, now let's replace this. Okay, let's have a huge array, something like this. Okay, let's have a huge array and let's try to find, is there any subset whose sum is 325? Is there any subset whose sum is 325? Let's try to find. Okay, let's replace this with sum. So this will be 325. Okay, now try to debug this. What is the array size? 31. Array size is 31 and you are trying to find, is there any subset whose sum is 325? Okay, now see the answer. It keeps on solving, so it enters the overlapping subproblems and keeps on recurring in the same thing. So we have to apply our caching technique. So in the question I will mention, okay, there are two varying variables, so you have to mention, right, 2D array, and in the question I will mention array size won't be greater than 50. Okay, so index won't be greater than 50, so cache will be cache of 51, and the sum value what I am going to declare here, and the sum won't be greater than 1000. Okay, I won't ask you to find any subset whose sum is greater than 1000. Okay, whatever the subset sum I am going to ask, it will be less than 1000 only. Okay, so it won't be greater than or equal to 1000. So we are defining cache of 51 comma 1000 of 1. So we have to set up the cache. Okay, void init cache for int I is equal to 0, I less than 51, I plus plus. Now for int j is equal to 0, j less than 1000 of 1, j plus plus, cache of I of j is equal to minus 1. Okay, what we have to do before calling the program, we have to init the cache. We are initting the cache. Now here. Okay, sorry, so I have declared it as int. Okay, we have to use it for no problem, we can use int also, not an issue. Okay, so it will store cache of for a particular index of sum is equal to, so before returning we are just storing what is the value for that. Okay, for that particular state we are just storing it in the cache and we are returning it. So if we are again entering that particular state, cache of index of sum, if it is not equal to -1, okay, so for true it will save it as 1, for false it will save it as 0. Okay, so initially we are keeping it as -1. So if it is not equal to -1 means it is either 0 or 1. So we are just returning from there. Now we applied our caching. Okay, now try to build and see. So earlier we didn't get the answer. Now with the caching technique we can get the answer easily. Yes, there is a subset. Okay, in that particular array there is a subset which forms whose group of elements which forms a sum of 325. Okay, fine. Okay, you can find the code link in the below description. See you in the next video. Bye.